We will be discussing about innate immunity, adaptive immunity, and types of transplants. In innate immunity, we will be discussing physical barriers, internal defenses, antimicrobial proteins, inflammation, and fever. In the physical barriers, this will involve the skin and the mucous membranes. In the skin, its cells are closely packed together. Keratinized cells makes it hard for pathogens to penetrate through, thus they enter through cuts, burns, and punctures. Mucous membrane lines all body cavities open to the exterior. It also produces a variety of protective secretion. It contributes to acidity of pH of skin, which inhibits growth of bacteria. Mucous membrane also has sticky mucus that traps microorganisms. Besides that, stomach mucosa secretes gastric juice, which contains hydrochloric acid and protein-digesting enzymes, which can kill pathogens, and saliva and tears contain lysozyme that destroys bacteria. Internal defenses, it involves phagocytes and natural killer cells. Phagocytes function to engulf pathogens by phagocytosis. There are two types, macrophages and macrophages. Then there's natural killer cells. They roam the body and they attack non-specific target. There are also spontaneous and they act on target by releasing perforin and granzyme. Antimicrobial protein, there is complement system and interferon. In interferon, they are small proteins secreted by virus-infected cells, which then diffuse to neighboring cells, stimulating them to synthesize proteins that can interfere with viruses' ability to multiply. In complement system, they refer to a group of at least 20 plasma protein, and in complement fixation, when they bind to certain structural protein, and can result to formation of MEC, membrane-attack complex. Another result is amplification of inflammation response and opsonization.
Then, let's take a look on the adaptive immunity. There are two types of adaptive immunity, which is antibody-mediated immunity that involves T cell. The next is cell-mediated immunity that involves T cell. Then, for the T cell, it is occur at cellular level. Then, the antibodies are inaccessible to those sites. Plus, the antigens are embedded in cell membrane or are inside the cell. Then for the B cell, it is used for production of antibodies. Next, for the origin of T and B lymphocytes, let's take a look on the picture that provided. Then we have three types of T cell. First is helper T cell, second one is cytotoxic T cell, and the third one is memory T cell. Memory T cell function dormant after the initial exposure to an antigen. Second exposure convert themselves into cytotoxic T cell and help fight the pathogens. Cytotoxic T cell function directly kill the infected cell. Helper T cell function secret interleukin 2 which stimulates cell division of T cell and B cells. There are two types of receptor in T cell. First is CD4, second is CD8. Next, let's see the T cell activation. T cell activation is a process where naive T cell gets activated into infected T cell or mature cell. There are two types of naive T cell which is immature CD4 plus cell which also called helper T cell. Next is immature CD8 plus cell which also called cytotoxic T cell. There are two types of APC. First is nucleated cell that express MHC1 and interact with CD8 plus cell. Second is non-nucleated cell that express MHC2 and interact with CD4 plus cell.
There are two types of adaptive body defense. First one is antibody-mediated immunity which involve B cells. Second is cell-mediated immunity involve T cells. There are four main in antibody-mediated immunity which are overview of antibody-mediated immunity, activation of B cells, structure of antibody, and types of antibody. Overview of antibody-mediated immunity. First one is mediated by B lymphocyte. Second one is B cells may be triggered to proliferate into plasma cells. Plasma cell will produce antibodies. Third, also known as immunoglobulin. Fourth, B cells mature in bone marrow. B cells are activated by the binding of antigen to the receptor on each cell surface which causes the cell to divide and proliferate. Some stimulated B cells become plasma cells, secrete antibodies. The arms of the worm make up the fat regions, also known as variable region, and the stem is the Fc region, also known as constant region. The molecule is made up of two identical heavy chains and two identical light chains. There are five types of antibody: IgG, IgE, IgD, IgA, and IgM. There are three roles of antibody, which are inactive antigen, bind antigen together, facilitate phagocytosis.
Organ transplantation is a medical procedure in which an organ is removed from one body and placed in the body of a recipient. Organ donor may be a living person, a brain dead person, or a dead person. Now there are several types of transplant, and the first one is autograft transplant, a transplant of tissues within the same person's body. The advantages of this transplant is that it offers the best regeneration result, but the disadvantages are have to undergo surgery 2 times, higher post-operative pain from second surgery, and the surgery is much more costly. The next type of transplant is allograft transplant, a transplant of organ or tissues between two genetically non-identical members of the same species. Advantages: no secondary procedure required, surgical time is minimized, and post-operative discomfort is reduced. Disadvantages: risk of transplant rejection and lifetime consumption of immunosuppression drugs. Isograft transplant of organs or tissues from a donor to a genetically identical recipient, which are twins, and due to being genetically identical, the recipient's body will not trigger an immune response, thus transplant rejection won't happen. Xenograft transplant, a transplant of organ or tissues from one species to another. Xenotransplantation is often extremely dangerous and risky. And that's all from us. Thank you for listening and thank you for watching. Goodbye.